Good morning, good afternoon, and good evening. Thank you for coming back to episode 2 of our listeners podcast. Following an incredible first episode with Sudhi Sinha, the author of Buildings 5.0, today we would like to welcome Dr. Yongchoon Park, a distinguished expert in buildings, infrastructure, systems, and power generation. With decades of experience in shaping the built environment, Dr. Park brings unparalleled insights into how technology, AI, and data-driven systems are transforming how we design, operate, and sustain modern infrastructure. And just so that you know, Dr. Park and I are going to be diving into the power-hungry needs of data centers and how he is working to address those needs through on-site power generation, a topic that is going to interest everybody. On today's episode, we are going to learn the future of power generation and smart infrastructure. We're going to be talking about how buildings and systems are evolving into intelligent ecosystems, the role of energy efficiency and sustainability in next-generation infrastructure, IoT automation, and how that is driving digital collaboration, and most important of all, how important is to be resilient and adaptable buildings are shaping an urbanizing world. So, enough from me. I would like to ask Dr. Park to give a short introduction about his illustrious career and how he is impacting the world today. Dr. Park.
Thank you. Thank you for having me, Emmanuel. And good morning and good evening, those who are in the audience. My name is Yongchoon, and I spent nearly 30 some years in the building in the power industry, where I spent over 20 years in Johnson Controls to build the controllers through all the way through building optimization and the chiller plant optimization. I went through the AWS to spend some time to build up the smart building verticals, and then I working for HANA QCell and driving sustainability through the power generations that it directly impacting on the infrastructure. So looking forward to have a dialogue with Emmanuel about that, how we're at tackling the world with the power independencies and so on.
Excellent. Thank you, Dr. Park. It's a pleasure to have you on our podcast, and we are delighted you could make the time to be here. So, Dr. Park, let me start off with the very first question. You and I know Sudhi for a very long time, and we've been friends for multiple years.
Mhm.
What are your thoughts on Building 5.0? And what are your thoughts on the substantial transition of the building industry into a digital first stage?
First of all, I was amazed at how much he is passionate about this and writing this like 300 plus pages book. I'm not sure where he found the time and energies to do that, but I ran through that book and it was amazing because first of all, his book talks about the beyond automation, which is obviously now we're just trying to do the HVAC automations and so on, but now we have to go into whole new next level of the automations from the energy management, occupant comfort, and audio visual security. This building's no longer like running into the siloed operational challenges, right? So automations from individual systems to the integrated system, then now is holistically you have to move forward. And also he touches up the those integration require a lot of data insight, a lot of challenges around the skills, which is very true for aging our workforces, and also design around the human-centric way, and also ESG-aware operation, which is not necessary to the energy savings, but starting from all the way through the construction materials to demolish, how the life cycle looks like, and then understanding of the importance of the life cycle management and adding AI and ML capability from all the way from design stage to the operation stage and then demolish stage. I think these are the one of the comprehensive book that I've seen in the industry, particularly practitioners view. So thank you and congratulations for Sudhi's that big accomplishment.
Excellent, excellent. No, I'm sure Sudhi will be delighted to hear that feedback coming from you, Dr. Park. So with that, Dr. Park, let's dive into a little bit about the evolution of buildings, infrastructure, and power. You started your career focusing on buildings and infrastructure. You've done some iconic projects across the world. You and I had the opportunity to be part of the world's first AI-enabled building out in the UAE. From your perspective, Dr. Park, how has the world of AI shape the world of buildings, shape the world of infrastructure that goes into buildings, and reset human experiences and human expectations on collaboration?
Um, the first to me is like let's a little bit step back to what really impacts on AI, right? The product centric view when like let's think of 10 years ago and 15 years ago. Everybody wants to put the smart cameras. Everybody wants to put them into smart thermostat, and everybody wants to do smart chillers. Well, it is just doing a little bit of independent, not aware of all the context about how the surroundings. And it would start out from the very small use cases, optimizing individual equipment levels and systems, but does not necessarily to give the holistic view, but also there's no way we can easily justify the technology because of the uh, the vertically integrated solution does not give you enough values to make that justification. And then it does not really integrate with the initial stage of the design. So the buildings was not really intended to run autonomously. HVAC system was designed to run at the constant temperature, not the fluctuating temperature. That's the promise of adaptabilities and things like that. So the overall, in my view, is initial stages as 80s and 90s and early 20s is more about the product centric AI and smart things got embedded into vertically. But now I think all the whole industry is looking into horizontally integrated with it from all the way from design, where hey, now you have the generative AI that actually design, simulate, and try that what is the best configurations for a placement of the rooms and then ventilation system, and how that brings into the operational side, where how systematically we can train and design an adaptive control system across the multiple domains from security, even HVAC side, right? Looking at the air side, and then the central cooling and heating and occupancies, and all this needs to be all integrated with it in a way that makes sure that holistic optimization or co-optimization per se is the way that operational efficiencies, and also day-to-day operation side, right? Make sure traditionally you have to prepare all of those your daily task with the checking few hundreds of set point check and so on and so forth. Now I think AI can help you your operations, even not just control and then operation, and also the predictive diagnostics, preventive maintenance that with the data-driven, AI-driven, help you to do more so that look at it as a more holistic and from the product-centric to system-centric, and then now system-centric to more holistic, building campus-centric and a portfolio-centric, and then more around embedded and kind of self-aware types of the scenario. That's the kind of use cases that I'm start seeing. And then I think that's how the future looks like going into it.
Thanks, Dr. Park. So you've seen that evolution where we started with buildings as a shell, buildings becoming intelligent structures, buildings then evolving into artificially intelligent ecosystems, support the humans that come inside them. And then with the advent of AI coming in, we are now looking at a new class of buildings, which is data centers. AI generates petabytes of data. This data is then used and harnessed for giving us results, insights, and intelligence. With the coming in of AI, we've created the new dawn of data centers sprouting up everywhere. And everybody talks about power and how hungry data centers are in terms of power consumption, in terms of water usage. What are your views, Dr. Park, as to the evolution of data centers? And how can we fulfill the demand of power that data centers would need?
So I guess the biggest challenges for data center owner or operator is, do I have enough land, right place, and the right power generation and water? So like geolocation selection is challenging. Once you found the geolocation, the next level is how you place them in a power balance between, because if I do the 100% self generation, it's not going to take up, right? It's going to take a while to get. So you have to get the grid connectivity, but grid may not be ready, and you have to put a substation and transformation, all this thing nearby, but they may not give you enough powers to power up. And also, it may not necessarily to meet your greenhouse gas emissions or ESG type, right? So the first is to how AI or the next level of design tools to find the location with the grid level, substation level, nodal level, design and simulation, which it ties with the grid twin and so on. That's kind of design side of the capacity you have to need. But also, traditionally, just your data center is just like a little bit of dumb, energy hungry infrastructure. I think we have to really hard look at with on-site generation, potentially a little bigger than your UPS store, but also how this on-site generations can participate the grid with, and then connect with the grid, and then dynamically interact with the grid while optimizing data center operations, which largely contributed by HVAC system. Probably 40 or above 40% of your electricity demand is all from HVAC, and then constantly real-time monitoring with server operation and others, right? All this needs to be traditionally run and operate. Unfortunately, it's a little bit independently. So holistic co-optimization give you additional 20-25% of the optimizing energy demand, but also the grid congestion relief. And these are all needs to be holistically designed upfront. Therefore, the operators can meet the time greenhouse gas emission targets and energy cost savings. But also, most importantly, we can support grid resiliencies, which is most concern from the utility providers. So I guess it no longer data center is just a unidirectional energy hub. The infrastructure it is participating in actively.
So let's zoom in a little bit on that last comment of yours, Dr. Park. You spoke of grid resiliency. Now, we all have known that as infrastructure consumers, buildings and data centers alike, are dependent on the grid. But we've also heard so many stories and challenges that the grid is having today with generating that amount of power. On one side of the world, we had power generation companies, that provide electricity as a utility, as a service that we all consume, that we all enjoy. These companies are now having a hard time supporting the demand data centers are taking up. Now, to support that demand, the organizations that are owning and operating data centers have to take care of redundancy, have to take care of resiliency of their DCs. And you're talking about on-site power generation. Is there a shift where now DC service providers are also going to become power generators, and how would they compete with existing utility companies? Is there competition? Is there co-opetition? How do you categorize them?
So I think that was an interesting question, conversations, right? So yesterday I had a brief chat with one of the utility companies, the executive, but also the commissioners from one of the state they are having exactly the same problem. Where that I see is the data center owners or operators with on-site generation is not really competing to the utility. Actually, utility will get a benefit. First of all, UPS plus backup, little bit of exercise with the extra storages that are not usable. And nearby, typically you have multiple data centers because of their location. Therefore, utility provide for one or two, whatever the necessary the configurations, will always suffer that demand, peak demand management and so on and so forth. So when it comes down into grid data center operator, every time I talk to them is very much around, it's not about competing, it's about providing risk, providing the risk mitigation strategies for utility, because they have to serve data center, but also serve residential and commercial customers they have. When balance is not there, then make a little bit of offloading of the demand from the grid by self-generating. And then if the grid requires more data from somewhere else, and potentially these excessive powers from standby unit or excessive power from the battery storages that data center has it, or renewable side, they could discharge some of those excessive parts to the grid so that dynamically coordinate that grid balance, which is resilience, which is most important part of the utility industry's transmission and grid stabilization. So that's how I kind of see it. And it's a more complement. It's not a compete.
Mm-hmm. Yeah, that's a very interesting point, Dr. Park, because if we look at digital services today, from how they have evolved over the past 2 decades, not even a decade, but the past 2 decades, digital services have become essential services, deeply integrated into our human lives today. Most of us today, without an internet connection, or without access to a good Wi-Fi connection, will find it very difficult to do what we're supposed to do. Then all of a sudden, along the way, comes the power of compute and the power of artificial intelligence, where we're saying, hey, we can help you be more productive. But the cost of that is the amount of power data centers are consuming. That led to the other problem where we don't have sufficient energy on our grids. And now our solution is, okay, great. We can do cogeneration on site. We can help meet some of that demand on site. Do you also foresee, Dr. Park, that with the data centers as the massive boom and growth that they're having and the amount of power they're going to be generating on site, would that also support consumer demands where they'll be able to support the grid in times of need?
So when obviously the grid of the data center operators' expectation is that their data centers to be like 100% capacity full run all the time in a constant, but it depends on the utilization of server and customer statistics, requirements, and so on. That's not the case. And also, there is always a backup generation unit that always standby unit, and then there is a lots of room that they play with. This to me is like it's a win-win situation with the grid service provider, utility providers as well. The reason behind that is building up the transmission infrastructure, particularly transmission capacity increases for the supplying all the utility need for consumers and so on. That's a massive undertaking cost for the utility service providers, right? So we're constantly renovating the transmission lines and substation infrastructures and expanding. That's a hundreds of $100 million investment that requires utility. If data center can contribute nearby substation levels to the supply certain demand with the understanding of grid congestion and constraint with the export limit, which minimum required to support or maximum required operating data center at the perfect stage, I think that's a pretty much the positive direction that even utility was open to have that level of conversations or interactions with the grid the data center that can participate some of those distribution, which eventually translate into form of some of those revenue sharings or risk sharings and so on.
Therefore, with that point, how much has technology evolved today with respect to on-site power generation, and what options do people have for on-site power generation?
Certainly, that is a lot of hot topics for everybody. In terms of like a solar and battery, I think that requires quite a bit of land spaces and also the time to deploy will take some time, but at least we don't want to say like sitting right next to data center or sitting adjacent to the data center and then actually totally offsite kind of thing we can think through, right? So, battery powered power plant, I think this is one of the projects that we do in Arizona to supply AWS, but I think that's one option, near site to that option and the battery storage, but that's more like utility scale. But on-site, the cases to me is like a larger battery storage and hydro option, and microgrid is another option. And then, to be frank, there is no such way we can actually eliminate the fossil fuel at this point with the demand. So we should be a little open for optimized utilization of the gas turbine or gas generated or diesel generated. So that you could design your source that optimize for cost or plus optimize for your greenhouse gas, knowing that you are going to go into the clean energy in the future, but to meet the demand, kind of hybrid infrastructure you have to do. But getting into the hybrid, gas turbine as an example, I think one other our organization is actually looking at the reverse the engine aircraft, which is now from the gas turbine aircraft engine becomes a generator, right? And then potentially hydro, um, and the battery storage and micronuclear reactors or micro grid. These are the types of the options that I see in the market at this point. But who knows? There might be other technologies coming in. But the cost effectiveness wise, I think still the traditional fossil fuel is the most cost effective.
Yeah, I think you brought up a beautiful point, Dr. Park, where the importance of hybrid power. No one source of power can meet the power demands that we have today as an entity, as human beings, as what we require in terms of our services, which brings me to the next part of the question, which could sound more philosophical in terms of what we're trying to do. But the question is, we have become dependent on digital services. We love digital services. It's a way that has brought worlds together. We are able to exchange information. We're able to connect with each other, speak to each other, be more productive in terms of what we build, create, and design much faster at a pace that our previous generations could not. And on the same side, we are now talking about sustainability, where everybody talks about how sustainable they are, how much sustainability practices they employ, and how they're looking to minimize their greenhouse emissions, how they're looking to optimize carbon emissions. But then on the other side, we have these behemoths of power consumption, which is our data centers that sometimes go under the radar. People don't even understand how much power a data center consumes. Mm-hmm. So on one side, we're talking about let's be sustainable, let's reduce emissions. But on the exactly other side, we are looking at building more data centers, consuming more water, generating more power. So it's almost putting us into a paradox. Our desire and quest for digital services, for intelligence services, is fueling power generation and power consumption. And that in turn is affecting sustainability. And I think the point you made, Dr. Park, is in the short term, it has to be mixed. We have to look at fossil fuels as an option as well. It's not going to go away. Do you believe, Dr. Park, that sustainability and digital services to data centers could coexist and we could come to an optimally sustainable solution that is good for us and good for the planet?
I guess this is a little bit of philosophical questions that I always try to answer. Is like, we don't want to be an extremist, like a far right and far left.
Right.
Because if we try to be like a totally net zero, then eventually open a lot of time I see as a pilot project and never really pan out at the scale because of the idealism about I want to be in a totally, then you go back to Amazon jungles and then live just by yourself. But we're in the social animals and we're almost digitally addicted and by human nature. So that I think this is fundamentally human natures and philosophical questions about what will be the acceptable way, but we don't want to forget about what is our North Star. And my approach is what will be the best way to get point A to point B, but it is very difficult to get straight line to make the travel to be optimal. We have to kind of hooping that harbors and harbors and harbors and offshores and shores. So the fossil fuel types of mix is, to me, is we all know that it may not be good for mankind, but we have to extremely cautious when to use, how to use. Similarly, gradually, that's why I think we have terms to get there, right? And instead of tomorrow we're going to do. So meantime, we give enough time to get technologies get pick up. And hopefully by the time that certain timeline, we want to be a totally fossil fuel independent and net zero nature, then our computational capability and AI, the computational demand advanced, so much advanced on a less require power consumption. Our infrastructure development and construction structures of our data centers and all these computational infrastructures, power demand getting lower and lower. And meantime, we have improvement of maximizing our either solar generation, like a from sky is an example, how we can increase the capacity of generations and so on, or battery storages to capacity handling, or the efficiency of the hydrogen power and cost effectiveness. So I think we have to look at those. One side, demand got diminished, they reduced, and then the demands for computation got improved. Therefore, we don't need the same amount of the power. I think like DeepSeek already sort of proving some level, but I don't know whether it's a reality or not. But the other side is how we can improve the generation side with the green, clean tech. These are the three things that we have to kind of keep the balance in our life. So,
No, that's a fantastic point, Dr. Park. I think what you have explained to us is basically saying that our needs as a nation have grown with respect to our digital services, but also our means to meet those needs through varied options of power generation that exist today that did not exist a decade ago, give us an option to be able to do it in a sustainable manner. So with that, Dr. Park, the pace of evolution has always been great. The pace of innovation sometimes has been really, really accelerated. With respect to data centers and with respect to power generation, if I ask you to take a minute and say, what is Dr. Park's vision for the future of coexistence of power generation and power consumption with a happy, safe, and healthy planet? How would you paint that vision, Dr. Park? How would you describe it to someone that's probably going to listen to this a decade from now?
I guess the first infrastructure that I'm looking at is first is more like one is going forward with the more green and clean energy adaptation. That requires the multiple things, right? One, our subsystem needs to aware that how much of the energy consumptions they have to optimize, but also whether the source that they are using is from fossil fuel versus green energy, so that depends on the source with the constraint that we put in for how much of the natural targeting, so that even individual device level, they need to aware and switching. Obviously, that will comes with a cost. Then if that's not feasible, then probably put them in the system level. Let's say it's a cooling system, when to cool with the grid, when you cool with Onsite, or cool with the battery or supplement. These are the types of the awareness that makes you kind of do. And the next level is the server side, and the next level is the buildings, the entire data center structure-wise. Those are self-awareness about the source, but also cost constraint. And then and also when to dispatch green energy that excessive in the data centers to the grid, so that you can build a balancing level. That's one way I see that. And second part is to overall, it is a futuristic, and then this entire digital infrastructure, supporting infrastructure needs to aware that will be a part of your transmission layer. So that understanding of all of those grid conditions, which potentially impact on other part of the delivery or demand. So that those are the coordination is a somehow, and the self-resiliency is the important pieces. And also this types of integration requires a extremely complexity of the security and operation. So the next level individuals who involved in design and development, I think some other credits on sort of the industry and ecosystems to maintain some of things. But that's how I kind of see that.
No, that's fantastic. Dr. Park, thank you so much for your time. And to all our viewers, this has been an amazing session where you got to hear from Dr. Park, one of the foremost leaders as it comes to buildings, automation, and power generation, as to what he envisions the future to be. The future is going to be a combination. there is no one answer or there is no a silver bullet. It is a mixed bag of what we know today and how that is going to evolve. So we as humans can continue to be social animals and can continue to collaborate and be more productive. Dr. Park, thank you so much for your time. Thank you so much for your sharing. We truly appreciate it, and we are looking forward to the next generation of data centers that are going to be powered through hybrid sources. Thank you, Dr. Park.